We're going to have a number of people that score 44 out of 44 on this test, I promise you. But then some people will have a crying moment on this test as well. So I hope it doesn't happen, but inevitably it seems to happen each year. Okay, so today we talk about function inverses. Function inverses. We've learned how to add functions. We've learned how to subtract functions. We've learned how to multiply functions. We've learned how to divide functions. And then on Thursday last week, what else did you learn how to do with functions?
The little circle thing.
Yeah, what's the circle thing called?
Composition.
Composition. You learned how to compose functions. F composed of G. That was really cool, right? And today I'm going to teach you a new operation, and it is function inverses, and it looks like that. That does not mean 1 divided by f. That's not what you do. Nothing like that at all. Don't write that, okay? So we need to teach you about what that means. Before I can tell you what a function inverse means, I first must teach you what it means to be a one-to-one function. And a one-to-one function is one-to-one if every element of the domain corresponds to exactly, anybody? One element of the range. Does that sound familiar?
Very.
Why?
The function definition.
That's the definition for a function. So like, why would we write it again? It's because there's more. And every element of the range corresponds to exactly, anybody? One element of the domain. Okay, we were talking about chickens last hour. Okay, chickens last hour. Some people only had 4 chickens. Some people had like 25. Anybody have chickens here? Just one? Okay, so we'll use Diego and Abby. Okay, all right. So suppose Diego's got chickens, and the output is the number of eggs that the chickens produce on a daily basis, and Abby's got chickens, and the output again is the number of eggs produced on a daily basis. Is it possible at the end of the day to see that Diego has 20 eggs and that Abby has, say, 16? Yeah, it's totally possible, isn't it? Is it possible for Diego to have 10 and for Abby to have 10? Yes. If I asked you which one produced 20, you would have said Diego's, right? If I asked you which one produced 16, you would have said Abby. But if I said which one produced 10, you would have said, well, it's one of the 2 of them, right? I'm like, no, I need one answer. You'd be like, well, it was both of them. Which would you want to pick? I'm like, hey, it's got to be one person. Like, again, so that's a problem. There are 2 people who produce that, right? That's because that situation is not a one-to-one function. They have to have different outputs. They can't have the same output. So what does that look like graphically? It looks like this. This is an example of a one-to-one function. We're going to play a game. You pick Y, I give you X. Okay? Connor, you ready?
Yeah.
I'm going to move my marker up and down the line. You tell me when to stop. Okay? Okay, you told me to stop right about there. If that's the Y value, I'm going to tell you this is the only X value that will give you that Y value. Adrian, you tell me when to stop.
Stop.
Oh, right there. All right. Then 0. That's the only X value to give you that output. Okay? All right. Now, if I change this, let's look at a function like this. Okay? Max, you tell me where to stop. Okay, you told me to stop right here. Well, it looks like I have an output there. So X is there, and then I also have one there. See, for every Y, I'm going to have multiple X's. That means that the parabola is not one-to-one, but the blue one is one-to-one. So in order for something to be a function, it must pass the vertical line test. In order for it to be a one-to-one function, it also must pass the horizontal line test. And there you have it. That's information about a one-to-one function. Okay. Now that you know about one-to-one functions, we need to learn about function inverses. In order for a function to have an inverse, it must be one-to-one. If it's not one-to-one, don't bother finding the inverse. Evie, when you yawn, it makes me feel like my class is boring.
It's not. I just yawn.
It's okay. I'm just joking. All right, here we go. Function inverses. Here's what it means to have an inverse. This is what F inverse means, okay? You're wondering what that thing means? It means that the domain becomes the range and that the range becomes the domain. That's what happens. It means that the x becomes the y and the y becomes the x. So I'm going to give you the most boring function in the world. Most boring function in the world I could think of is 3, 8. It's just a dot. It's 1 point. Anybody want to guess what the inverse function would be?
8, 3.
Yeah, it's 8, 3. Now, try to make a point here. Being this is a function, I could say f of something gives you something. And we always put an x value in there, and we always get a y value right there. Okay? So f of 3 is equal to what?
8.
8. And so if you do f inverse, you're taking a y value and plugging it in there, and you're outputting an x value. So suppose I had f inverse of 8. What is the x value that produces a y value of 8? 3. So that's why we say it has a coordinate of 8, 3. It switches spots. Okay. All right, we'll get to the tests and the graphical. We got to do those later. Let's move on to the next piece. Example 1, it says given f of 2 is 3, and given f of 1 is 9, and f of negative 3 is 8, and f of 4 is 5, and f is 1-to-1. Yay, it's 1-to-1. That means we have inverses. Find the following. F inverse of 8 means if we have a y value of 8, what's the x value? Negative 3. Okay, Hannah looks, she sees that guy right there. Negative 3 is the answer. F inverse of 3, by that would be positive 2. F inverse of 5 is 4. And f inverse of 9 is 1. Easy enough? Okay, we're going to switch it up. It says f of x is 3x minus 8. Find f inverse of 6. Is 6 the x value or the y value? It is the y value. We're trying to determine the x value. So notice that my function says 3x minus 8. Y is equal to 3x minus 8. Anybody want to have an idea for how I'm going to find the x value? Yes, I take 6 and drop it in for the y value right here. So 6 equals 3x minus 8. I add the 8 and I get 14 is equal to 3x. So therefore x is 14/3. So now the question is simple. What is f inverse of 6? Well, we can see the y value is 6, the x value is 14/3. What do you think? Not too bad? Take out your calculator, graphic calculator. Go, go, go. This is my favorite part of the lesson. I think this part's pretty cool. It says find the inverses of the following functions. We're going to use our calculator here to confirm that. But right now, we don't just simply find inverses of points. We are also going to find the inverse of the entire function. So notice that this is like y is equal to 2x minus 5. In order to find the inverse, we flip the x and the y values. And this becomes x is equal to 2y minus 5. All we do is we swap the x and the y's, and then we solve for y. I add 5 and get x plus 5 is equal to 2y. And I divide by 2, and I get x plus 5 divided by 2 is equal to y. If you would like to write that as 1/2 x plus 5 halves is equal to y, you're okay as well. Either way is just fine. You good with that? Which way would you choose to write it?
Probably just the top way.
Top way?
Too.
Me too. But if I plug in my calculator, I like that way, because that way requires parentheses. Crazy stuff. Take it out. Here we go. Go into y equals. And we're going to wonder graphically what this looks like. Now, that example is pretty easy, but me as a teacher, it's like when I find the inverse of something, how do I know it's right? Like, how do teachers know they're right with their answers? They find ways to check their answers, and here's a great way to do it. I'm going to type in the first one, which is a 2x, and was it plus 5? 2x plus 5 or minus 5? Minus 5, so I got a minus 5. And then the next one was 0.5x, and it was plus 5 halves, 5 over 2, or 2.5. I'm going to type those two in. Let everybody else do that. And then to make sure we all see the same picture, I press Zoom 6, Zoom Standard. Ooh, I like what I got. Here's something interesting. Notice the blue function has a y-intercept of -5. The red one has an x-intercept of -5. The blue one has an x-intercept of 2.5. The red one has a y-intercept of. And in fact, if I go in here and do one other thing, this is the really cool part. I type in x, just y equals x, which is a line, okay, with a slope of 1 that passes through the origin, and I graph that. The line y equals x will always divide two inverses perfectly in half, such that one would reflect over the line to produce the other. One would reflect over the line to produce the other. We're going to look at another example of that in a second, but I'm going to write that down right up here. It says graphically they are reflected over the line y is equal to x, and I use that all the time in my checking. Okay, let's find the inverse for problem number B. Letter B, I've got y is equal to 2 minus x over 3x minus 4. What do I do to find the inverse? Swap them out. X is equal to 2 minus y over 3y minus 4. Oh boy, I got to solve for the y. I got y's in multiple places. What do? Wouldn't it be nice if your teacher had taught you this already? Like in chapter 1.5? What do?
You cross multiply.
Cross multiply. X times 3y is 3xy. X times 4 is 4x. And then 2 minus y times 1 is 2 minus y. Now what?
Get the y's on one side, factor them out.
Excellent. Gather the y's all on one side. 3xy plus y is equal to 2 plus 4x. Now, the conundrum here is that you got y's in two different places. How do we isolate it down to one? Ben already told us. He said factor that y out to isolate it. Y times 3x plus 1 is equal to 2 plus 4x. Divide by the 3x plus 1, y is equal to 2 plus 4x over 3x plus 1. Now, we're not going to check that, but can everybody see that you might be less confident about that answer than you are about the previous one? And so verifying by looking to see if they're across the line y equals x, that could be a good thing. Flip it over. Let's try an easier one. I'm going to change this problem because I don't like it. And change to f of x is equal to x cubed plus 6. I want to find the inverse, so what should I write? X equals y cubed plus 6. I solve for y, I subtract that 6 over. X minus 6 is equal to y cubed. As we cube root both sides, we have the cubed root of x minus 6 is equal to y. You don't have to type it in, but I'm going to type both those into my calculator if you want to watch along so you can see, are they in fact reflected over the line y equals x? And I've got x raised to the third power, and I'm going to add 6. And then for the next one, if you want a cubed root ever, you go into math, you grab number 4, that's cubed root, and you have x minus 6. And I'm going to check out these graphs. What do you think? Does it look like one is reflected over that line to produce the other? Absolutely. Okay. Actually, it looks kind of artistic. Who has natural art ability in here? Who's my real drawer?
Why are you putting on me, bro?
Sophie? No. Juan? No. Grant?
No.
Autumn? Autumn can draw. Autumn admits it. You can draw, can't you? Okay. There's my art. Give me a grade. Oh, wow. Oh, man. God, that kind of... Can you imagine, like Emmy gets done with Dorothy, and afterwards, like, a walkthrough, and she's like, how would I do? I'm like, oh, okay. We'd never do that. It doesn't matter how you got me. Like, you're amazing, Emmy. Okay, that's what I'm going to say. My art's just okay. You're right. It is just okay. I'm going to try harder next time. I'll tell you that. Okay, next one. This is where it all comes together here, okay? All right, all comes together here. X equals 4 plus the root of y plus 1. Okay? Love this example. It shows so many elements to what we're talking about. I subtract the 4, I get x minus 4 is equal to the root of y plus 1. I square both sides, and I get x minus 4, quantity squared, is equal to y plus 1. I'm not going to multiply that out because I can see right now it's going to be what kind of shape? A parabola, and I can see it's going to be in vertex form. Vertex form is helpful. X minus 4, quantity squared, minus 1 is equal to y. And at this point, I can't give you all the points on the test for that because this is not the right answer. Something has to trigger in your mind here, and I don't know how to get it. I'm doing my best to help you see it. But what shape does that thing make? Okay, see Connor do that. Everybody on board there? What shape does that make? Does everybody agree that if you flip that, you don't come up with that? So what happened? Something crazy happened when we squared both sides. We produced more of the graph than what we wanted. So in order to figure out what to do, I'm going to try to show you a little bit of a graphical representation of this. And the graphical representation is pretty easy because you're really good at graphing. You know that has a horizontal shift of what?
Left 1.
Left 1 and vertical shift of?
4 up.
Good. So I'm going to plot that right there and draw it off to the side. And while I'm at it, I'm going to write the domain and the range so I could get a deeper understanding of this. What is the domain of that?
Yeah.
-1 to infinity. What's the range?
4 to infinity.
4 to infinity. Good. Well, if I look at my new function I came up with for the inverse, I can see that that's a shift to the right 4 units. And it's down 1. So it's located right there. You tell me, if you were to flip that blue across the line, y equals x, would you come up with the green or would you come up with the yellow?
Green.
The green. Everybody agreed? You actually want to eliminate the yellow part of the graph. So the way you do that is you say, this is my answer, but I only want half of it. And the way you say I only want half of it is you restrict the domain to only the green. What's the domain for the green?
4 to infinity.
4 to infinity. Do you see 4 to infinity anywhere else on the board?
The range.
Yeah, because we said that the domain and the range will flip spots, won't they? And so you can see that connection right there for you. So this is your answer, because a parabola is not one-to-one, does not pass the horizontal line test, so it cannot be an inverse. So you have to cut it in half so it is one-to-one. There you have that. Good. All right, we're at our last piece. Last piece of the whole unit. Oh my goodness. Wow. It really wasn't that bad. The next unit is my favorite unit of the entire year. Well, not year, semester. Definitely semester. It's hard to beat trig. Come back to this side. Test to see if things are inverses. Test to see if things are inverses. Okay, that's where we're at right now. So I'm going to show you a couple examples you already know. For example, 3 plus -3, that produces 0. So 3 and -3 are inverses under the operation of addition, because when you add them, you get 0. Okay? We also know that, say, 1/5 is an inverse of +5, because when you multiply them, you get 1. So back in the day, you talked about inverses and operations, coming up with 0 or coming up with 1, they're inverses. Well, with functions, it's different. If you compose them together and they produce x, then they are inverses. But composition is not commutative. So therefore, you have to check it both ways. F of g of x, and g of f of x. They both must produce x. And if they do, then they are inverses. So let's try the example. It says, use the property inverses to determine if f and g are inverses of each other. The special property we're going to do about inverses is we are going to compose them. So I'm going to compose f of g. Fortunately, you're really good at this. You did this last week, Thursday. I take g and I drop it in for x, right there. And I get 3 times x plus 5 divided by 3 minus 5. Now you already know the answer should be what? You come up with x, right? But if you just write x, I don't give you points. You got to show me how you come up with x, okay? And those of you who have horrible handwriting, make sure I can at least read what you're putting down on your paper. What's the first thing to simplify here as we try to come up with just x? What cancels? The times 3 and divided by 3. So I end up with x plus 5 minus 5. And then what does x plus 5 minus 5 give me? This gives me x. That worked out pretty well, didn't it? It's not enough to just compose it that way. You must compose it the other way as well. I do g of f. So now I take f and I drop it in here. And we get 3x minus 5 plus 5 divided by 3. What's the first thing to simplify there?
No, plus 5 minus 5.
Plus 5 minus 5. So says Benjamin, I get 3x divided by 3 is just x. Is your given name Benjamin?
It is.
Is your given name Alexander the Great?
Yes.
Oh, wow. That's pretty presumptuous. Who are we to judge, Connor? Okay, well, I'm just warning you. What happened to my boy Kirk Cousins? Done for the season. That's too bad. Yep.
He's playing so good.
Yep. He had it rolling. Okay, I don't want you to actually solve these next two to be equal to x, but I would like you to write out the first step, see if you can plug them in correctly. These two are fractions. Sometimes people struggle to write this out correctly. Take about 30 seconds or so, see if you write that, and we'll go over it. So fun to beat Green Bay yesterday. I can't stand Green Bay. Hannah, you watch the game?
I listened to it.
Oh, good for you. Do you on a weekly basis?
Yeah.
Football fan. You're a football fan.
I guess.
I mean, we had everybody watching my house yesterday. Okay, here's what I should see from you. Okay, show somebody next to you and see if you can actually read that same thing on paper. If you can't read their handwriting, tell them. Say, I cannot read what you just wrote down.
Well, that's because I scribbled this.
Diego's calling out Grant right now.
It looks fine.
I'll be the judge.
Don't erase anything. What is that supposed to be?
Oh, okay, so that's me simplifying.
Okay, all right, I got you, dude. I got you. Yep, you know what? You're good. You're good. You're good. Don't let him hate on you.
I know.
Don't let him hate on you.
I gave him a compliment and then he said, "You're sacked."
Oh, wow. Okay. Just like that, too, in that voice. I like it. All right, let's look and see what simplifies. The plus 2 and the minus 2. I get 1 over x. Now I've got to do that. Some people get confused by that. The top fraction is 1 over 1. The bottom fraction is 1 over x. How do I simplify that?
1 over 1 times x.
Times x over 1. And what do you get? X. Great. So in the second part, do I first do the reciprocal or do I first subtract 2?
Reciprocal.
Do your reciprocal operation first, and you get x plus 2 minus 2, which is x. Great. Letter C, talk to the person next to you. It says f of x equal to 4x squared. Hey, come on, don't do that. Hey, now, okay. 4x squared is f of x equal to 4x squared for x greater than or equal to 0, and g of x is equal to root of x over 2. Parents share for 30 seconds. Why do you think it says x must be greater than or equal to 0? Talk to your friend. Go, talk.
Because
Well, this one can be positive or negative. This one can only have x. So it's gonna be like where we did that thing, where it's if there's like this, and we got something like this, positive x can't have one part.
Yeah,
Just have
that can happen.
this.
You can't get the square root of a negative. Okay, for this number.
Okay, eyes up here. Okay, some people are right, some people are wrong. What shape does that make?
Parabola.
Is a parabola 1 to 1?
No.
No, it's not 1 to 1. So you have to make it 1 to 1. So we're going to cut off half of it. Which half did we cut off? The positive half or the negative half? We cut off the negative half. See that? That's why it says that. Now it's a 1 to 1 function. So let's compose f of g. The composition is pretty easy. We take g and we drop it in here. And we get 4 times root of x over 2 squared. I get 4 times. What do you get if you square the root of x over 2?
Yeah, x over
x over 4. Multiply those, you get x. I now have to compose g of f. So that means I take 4x squared and I drop it right in here. And I get the root of 4x squared all over 2. What is the root of 4x squared?
2x.
I get 2x divided by 2 is x. Sometimes they will not be inverses of each other. We do this last piece, we're just going to compose it once, not twice. I'm going to put this right in for x there, and I get 1 over x cubed, that quantity cubed.
Wow.
In the top, I get 1. What do you get in the bottom? 1 over x to the ninth. What is 1 over x to the ninth?
X to the ninth.
X to the ninth, and that is not x. So therefore, they're not inverses. Hey, nice job. You made it through the whole unit. Okay? You have 4 tests this quarter, which is a good thing because that means the value of each test diminishes. If you only have 3 tests, then the value of each test rises. So this test will, be a little bit tougher one. The next one goes really well. One after that, not always so good. Okay, but that's it. You should be ready to complete all of your homework. Answer key is posted, and we'll give you some more time tomorrow.